everyone. Today I'm on my way to ESTEC, which is in Noordwijk in the Netherlands. ESTEC is ESA's largest center. It's our technology and research center where most of the scientists and engineers work. It's where most of our space hardware and satellites are designed, built and tested. We have the giant vacuum chambers, the vibration test stands where we can put satellites through their paces before sending them into space. And I'm going to go talk to some of the engineers working on the technology demonstration projects that I'll be working on board the ISS later this year. In particular, the robotics experiments, haptics and Meteoron. So it should be really interesting for me to get to know a little bit more about the work that I'm doing on the ISS. So I'm really looking forward to it. It should be an interesting day. I'm with Andre at ESA's Telerobotics and Haptics Lab. You're going to show me a little bit about Haptics 2 and Interact, which I'll be running from the space station hopefully in September.
Right. Let's have a look. We have a setup here which is called Haptics 1. It's currently on the space station, operated already by a NASA crew member and going to be operated by 5 more crew members. What this is a tablet PC that guides through an experiment for human identification, and we have a force reflecting joystick here, or in the medical world they call it an ergometer, to measure really interaction of humans and mechatronic systems. So we'll be installing here new software such that you can use the tablet and the joystick to do the Haptics 2 experiment, which is going to be the first teleoperation from space to ground with force feedback into space. So what you can do is actually, with your hand controlling this joystick, by this action controlling another joystick on Earth and feeling the forces reflected to your arm, and we'll give you a set of tasks to discriminate stiffnesses and so forth, and ask you to shake hands with some famous people probably.
Cool. And this is to get some baseline data for your future robotic arms, which are over here, which are really, really cool.
Right.
Should we go have a look at them?
Let's have a look at the SAM portable exoskeleton. That's a more advanced joystick controller, actually, an exoskeleton control device which has 7 joints, and it actually allows you to intuitively switch your arm in there and move together with it. And when you move it, you can actually control robotic arms as intuitively as you would control your own arm. And this device will also feed back forces to the astronaut arm such that he can exactly feel what is going on at the remote site.
And so you're controlling this robotic arm over here now.
Right, that's our lightweight manipulator, which is a soft robot arm that is actually safe to interact with humans. And it's now in a compliant mode, so it's interacting here with the task board, which has several elements like opening doors. You can extract drawers and sliders, packs, and your task actually in the Interact experiment will be to retrieve such a pack in an outdoor task board with a rover, drive to it, get it out, and actually place it into another location, which is really a mechanical joining task that requires quite some dexterity. So you insert this is sub-millimeter tolerance, titanium on brass, and you're actually latching it in place.
So this robotic arm by September will be installed on a rover.
Right. It's actually the rover you can see on the poster over there. The Interact Centaur, which has 2 robot arms that will be packed to be water and splash proof, because we'll take you outside actually with the rover. It's a 4-wheel drive, 4-wheel steer platform of about 400 kilograms. With the camera head, a 6-degree freedom camera, and actually 2 7-degree freedom arms with grippers that you can use to do all sort of mechanical assembly and joining tasks. And this guy here is fully autonomous, so it will be controlled on Earth via a cellular mobile phone network. So you from space will send data through 2 links to Earth, here to the lab, which will go onto cellular network, and then we can operate this anywhere on the globe.
Fantastic. This is going to be an exciting experiment. Can't wait to do it from space.
Yeah, I'm looking forward to train you actually, and to get our hands dirty with it soon.
Excellent. Thanks a lot, Andre.
Thanks.